Dear students, today we are starting Geometry second chapter, Pythagoras Theorem. This is the title of the chapter or the lesson. Out of the first point is similarity and right-angled triangles. Similarity and right-angled triangle. Here it means what? A right-angled triangle, a right-angled triangle ABC, right angle at B. From right angle B, perpendicular drawn to the hypotenuse, divides the original triangle into two triangles. Triangle ADB, the smaller one, the another triangle smaller one, triangle BDC, that also right angle only, and the original triangle ABC. All these three triangles are similar. What is the statement? In a right angled triangle, if the altitude is drawn to the hypotenuse, altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle. The two triangles formed are triangle ADB and triangle BDC. These two triangles are similar to the original triangle ABC. And also these two formed ones are also similar. This we have to prove. Means what we have to prove? Triangle ABC similar to triangle ADB similar to triangle BDC. Means what? Triangle ABC similar to triangle ADB. Also triangle ABC similar to triangle BDC. This is what we have to prove. And we are starting the proof. We take two triangles. The small triangle ADB in triangle ADB and the original triangle ABC. Now what you are considering, angle A is congruent to angle A itself. What is reason? It is common angle. Common angle. This angle belongs to the small triangle and also to the big triangle. Now, the second angle, angle ADB, is congruent to angle ABC. What is reason? Each is a right angle, 90 degree. Therefore, what happens? Two angles are respectively congruent to two angles of another triangle for a given one-one correspondence between their vertices. Then the triangles are similar by AA test. That's here we are using. Triangle ADB similar to triangle ABC. This we consider first result. What is saying? Angle A common and the right angle. The small angle, angle A and angle 90 degree. Here also angle A, angle 90 degree of the bigger one, congruent. Therefore, they are similar by AA test. AA test for similarity. Now we consider the small triangle BDC. And the big triangle ABC. Here this is a common angle. We have to see it. Common angle, right angle. Common angle, right angle. That's the order. In triangle BDC and triangle ABC. We say first common angle. Angle C congruent to angle C. Common angle. This angle is common to the small triangle as well the bigger one. Then we say 90 degree angle. Start from this angle itself. Angle CDB is congruent to angle CBA. Here each is 90-degree angle, right angle. Here also two angles are congruent. See this angle and 90-degree angle, this angle and that 90-degree angle of the bigger one. Therefore, triangle BDC is similar to triangle BDC. So ABC. What is the reason? By AA test. This is our second result. Now we combine both. The theorem is over. Therefore, from 1 and 2, we combine this. First, we are at the bigger triangle. Here, triangle ADB, similar to triangle ABC. The small triangle BDC, similar to triangle ABC. Therefore, small triangle, we write ADB, similar to this small triangle BDC, similar to triangle ABC. This is what you are getting. What you're doing, see, start from angle A, go to perpendicular angle, 90-degree angle, then C. Same thing, angle A started, go to 90-degree angle, and the third angle B of this small triangle. Again, start from this angle, go to 90-degree, and complete it. It's easy to remember, see, like this. This is the order. Then start from here, then come to the 90-degree angle, then start from there, go to 90-degree and complete it. Start from here, A, B, C. Start from A, then D, then to B. And then start from there. Where you stopped, reached there, from there, B, then D, C. So A, B, C, order, A, D, B, then B, D, C. The triangles are similar. This is similarity and right angled triangle. Now we have to go for, this is also called as BD, perpendicular drawn, that is known as geometric mean. We do here itself. We take this smaller triangle, ADB, triangle ADB similar to triangle ABC. For here we take BDC. This already proved. Therefore, BD square V1. Here it is BD upon DC or CD is equal to AB upon BC. That is in triangle ADB similar to triangle BDC, ADB similar to triangle BDC. The smaller two triangles we consider, we write here BD upon CD is equal to this AB first and third letter contained inside here BC, also that is equal to AD upon BD. Strictly speaking, we want these two ratios. From here, see BD upon CD is equal to this AD upon BD. What is the reason here we can give? Triangles are similar, corresponding sides are proportional. Theorem by theorem. Triangles are similar, corresponding sides are proportional. Now cross multiply. BD into this BD equal to AD, AD into this CD. That is BD square. BD into BD, BD square is equal to AD into DC or CD. We have BD square is equal to AD into DC, AD into DC, CD or DC, AD into DC. This is what you are getting as geometric mean. This is extension of similarity and right angle triangles extension only. BD square is equal to AD into DC. That is also we come across, we completed now. Now we have to pass on to Pythagoras theorem, moving part. Pythagoras theorem. What is Pythagoras theorem? Earlier we studied in the earlier standard. In a right angled triangle, square of the hypotenuse is equal to the sum of squares of the other two sides. Here also statement is the same thing. Statement of Pythagoras theorem. In a right angled triangle, the square of the hypotenuse is equal to the sum of squares of remaining two sides. Square of the hypotenuse is equal to the sum of squares of remaining two sides means AB and AC, like this. Square of the hypotenuse is equal to the sum of squares of the remaining two sides AB and BC. AB square plus that BC square. Or also AB square plus BC square equal to AC square. This is a statement of Pythagoras theorem. This we have to prove. So we write proof. What we do here? Triangle, the small triangle ADB similar to triangle, the big triangle ABC. What is the reason? Just the previous one. Similarity and right angled triangles. This we got. Now we write here AD. Actually, we have to get AB square. So here it is. We start AB upon AC is equal to AD upon AB. Third side also we can write BD upon BC, but that is not required here. Triangles are similar. Two triangles are similar, therefore their corresponding sides are proportional. Cross multiplying this AB into AB square equal to this AD into AC. This we call equation number 1. Now, in triangle BDC, and triangle ABC, big triangle, the smaller triangle and the original big triangle. In this one, these are similar actually. We can write similar. Triangle BDC similar to triangle ABC by theorem that we have. The same theorem. Similarity and right angle triangles. Triangles are similar. Therefore, now we take a BC square. BC upon AC is equal to this. BC upon BC. See, BC square we have to get, So, BC, first and third letter, BC upon AC is equal to BC upon this BC. The triangles are similar, therefore sides are proportional. Cross multiply BC into BC, BC square is equal to this BC into AC. This we call result number 2. Now we add these two. Adding first and the second results, we get what? AB square plus BC square. AB square plus BC square. Left hand sides we are adding. Equal to right hand sides also we have to add them. AD into AC plus this DC into AC. Now you see AC is common, take it out. AD plus DC into that AC. AC is common, we are taking out. Then AD plus DC. What is AD plus DC is equal to? AD plus DC. AD plus DC is equal to AC. AD plus DC equal to full AC. So this is AC. Into this AC. That is AC square. This is what you're getting. AB square plus BC square equal to AC. Therefore, we write according to the statement, in a right angled triangle, square of the hypotenuse is equal to the sum of squares of the remaining two sides, that is AB square plus BC square. AB square plus BC square. This we can write, or you can write the other way, side changing, AB square plus BC square is equal to AC square. One of the same thing only. This is Pythagoras theorem. Pythagoras theorem. What is Pythagoras theorem? In a right angled triangle means given triangle is a right angled triangle. Then square of the hypotenuse is equal to the sum of squares of other two sides. Now another theorem is there, converse of this Pythagoras theorem. What they give? Just opposite way. If in a triangle square of one side is equal to the sum of squares of other two sides, then the angle opposite to the greatest side is a right angle. What you are saying in converse of Pythagoras theorem? If in a triangle square of one side equal to sum of squares of other two sides, means this is given. If AC square is equal to sum of squares of other two sides, then angle opposite to the greater side AC, this side's opposite angle is a right angle. That is given in the statement in theorem. What you have to understand? In Pythagoras theorem, given a right angled triangle, whereas in converse what you are doing, we are proving that angle is a right angle. In Pythagoras theorem, in a right angled triangle, square of hypotenuse equal to sum of other two sides. In converse is what? Given one side square equal to square of other two sides. The result what we proved in Pythagoras theorem is given. In Pythagoras theorem given it a right angle in a right angle triangle means it is given a right angle triangle. That is what we have to prove in converse theorem, converse of Pythagoras theorem. Agreed? Understand? Very clear, very simple. In Pythagoras theorem given right angle triangle. Then we prove AC square equal to square of hypotenuse is equal to sum of squares of other two sides. In converse is what happens given square of one side. We are not telling Pythagoras theorem. Sorry, it is hypotenuse line. Square of one side equal to sum of squares of other two sides. Then, if that condition satisfied, then angle opposite to greatest side is right angle. Please go through it. It is easy. You will get it easily. Not getting, you make a note. We will explain to you very clearly. That is also very simple. Now we pass on to the other two things what you studied earlier. Now just we have to say what is it. This is not a proof required. It is not to be proved, but you have to take. In 30 degree, 60 degree, 90-degree triangle, in a 30, 60, 90 triangle, side opposite to 30 degree, AB equal to half of hypotenuse AC. This you studied in the previous standard. Now we have to just remember. What is it? Side opposite to 30 degree. Side opposite to 30 degree angle. This 30-degree angle, side opposite angle is, opposite side is AB. Side opposite to 30 degree is half of hypotenuse. Then this BC. Side opposite to 60 degree. Side opposite is 60 degrees what? Root 3 by 2 times of hypotenuse. That is side opposite is 60 degrees of this BC. That is BC is root 3 by 2 times of hypotenuse AC. Here AB is equal to half of AC. Side opposite to 30 degree AB equal to half of hypotenuse AC. This you have to remember directly. In application part, we have to do this in doing or in solving problems. Theorem is not required in your syllabus, so we pass on to 45, 45, 90 triangle. 45 degree, 45 degree, 90 degree triangle. 45, 45, 90 triangle means what? One angle 45 degree, one angle 90 degree. Obviously, the third angle is 45 because it is 90. Sum of these two angles 90 degree. Therefore, 45, 45, 90 triangle. Side opposite to 45 degree. Here also they are equal, congruent. Now what is that? Theorem says side opposite to 45 degree is equal to 1 by root 2 times the hypotenuse. Means what? Side opposite to this 45 degree AB equal to side opposite to this 45 degree BC equal to 1 by root 2 into AC. This is this much only for 45, 45, 90 degree triangles. This also very easy. So what and all we did today? First we did similarity and right angled triangles or right angled triangle. What will they? There we put a right angled triangle perpendicular drawn on hypotenuse. Then we give some namings A, B, C, and D. There we proved triangle ABC, big triangle ABC, similar to triangle ADB, that is similar to triangle BDC. ADB, then BDC. That is first point what you have to understand, proved today. Second point is what we proved? BD square. BD square is equal to AD into DC. Then third is what we have proved? Pythagoras theorem. Pythagoras theorem. What is that? In a right angled triangle, suppose we take this as ABC. Pythagoras theorem says what? Hypotenuse square is equal to AB square. The remain sum of the squares of the remaining two sides. AB square and DC square given right angled triangle. Then what we discussed? Converse of Pythagoras theorem. What is converse? If square of one side equal to sum of the squares of other two sides, then angle opposite to greater side, that is the greatest side, hypotenuse, like greatest side is a right angle. This is converse of Pythagoras theorem. Then what we discuss finally here, 30-degree, 60-degree, 90-degree triangle. Here what we got? Side opposite to 30-degree. Side opposite to 30-degree is half of hypotenuse. Side opposite to 60-degree is what? Root 3 by 2 times hypotenuse. Then what we come across? And the last point, 45-degree, 45-degree, 90-degree triangle. What was the result we got there? Side opposite to 45-degree. Side opposite to 45-degree is what? 1 by root 2 times hypotenuse. All these points, please be thorough today itself. Tomorrow we do its application, the exercise part, solving problems. Today we stop with this. All of you please do all these things thoroughly. Thank you.